This video is going to demonstrate basically three things. We're going to demonstrate something called operator overloading, which is a way for us to actually redefine what double equals means. We saw in our last video that I cannot compare two objects. Oh, I deleted that line of code. We can't compare like lion location to zebra location with a double equals because it doesn't recognize the double equals operator for structures. Well, you can actually redefine that, and we're going to do that. It's also going to cover what's called an inline method, and an inline method is a method that you write all at once. You don't define a prototype for it. You don't separate the prototype and then the implementation of the code. It's just written once, and I have hidden it here. So let's take a look at what we do here. So first of all, to overload an operator, we have to use the reserved word operator, and then we have to tell it what operator we're overloading. So we happen to be overloading the double equals. I could override something like, I could override the plus plus operator, I could override the minus minus operator, I could override the less than operator, etc. We are trying to override the equals operator, so we're going to do double equals. We are going to write it as an inline method, so we use this reserved word inline as well. And then we're returning a Boolean. So return type, it's an inline method. I'm going to overload an operator, and then I have to list the operator I'm overloading. In this particular case, I need two things. I'm going to overload an animal, so I'm going to pass in two animals. In this example, I'm using a constant animal 1 and constant animal 2. They are not passed by reference. That they're constants so that nobody can change that value locally. And then what I do is I compare the names to see if they're equal, the species, and the weight. And what I do is if they are not equal, exclamation point here, if they are not equal, I'm going to return false, and that breaks out of the code and exits immediately. So if any one of these three is wrong, it returns false. If it passes all three of these tests, it returns true. And that's for comparing an animal to an animal. So if I scroll down in my code and take a look at comparing two animals, okay? So I'm going to see if my lion is equal to my zebra, and this is actually the similar type of code that we tried before. When we tried this before, we could not compare a structure directly with another structure. I could not compare let's say an animal to an animal because it didn't know what to do with double equals. Because now I've defined it as and I've overridden that operator, then it should work. And it should print out lion, they are different because they are different. So I'm going to hit run, and we're going to see what happens. And it says animals are in different enclosures and animals are different. So the animals are different, they should be in different enclosures, so that makes sense. So what we just did is we overrode the double equals operator, and basically you're now kind of writing, you're redefining things and how they interact. So you can redefine operators. That's called operator overloading. So now what I want to do is if I want to do that with all of them, I'm going to copy that code, and I'm going to also do that for location. And so I'm going to override the operator again, but now I'm going to do it for location. Instead of an animal, I'm going to use location and location. And location only has two things to compare, and that's the enclosure ID. So I'm going to copy that. So we're going to check to see if one dot enclosure ID double equals 2 dot enclosure ID. I'm going to return false. And copy and paste is kind of nice because then we avoid some typos. And we're going to compare the enclosure names. It's nice in C++ because double equal actually works to compare strings, so that's nice. And then I delete this third one because I don't need it when I am comparing locations. So now I could replace my code that I used down here where I called compare locations and sent it a lion and a zebra. I'm going to comment out that one line of code, and I'm going to replace it with if lion location double equals, because I have now overridden that operator, zebra location Then I'm going to say animals are in same enclosure, etc. So cross my fingers. I haven't tried this. We're going to see if it works. And they are in different enclosures, and animals are different. So thumbs up, that works. We just have one more operator overloading to do, and that is going to be with our zoo animal. So the process is going to be the same to do that. So I went ahead and wrote the code for my overloading the operator for zoo animal. And so in order to do this, I have to compare the integer animal ID, and then I just use the animal and then the location. And what it does is when it compares these two animals, it actually calls the other inline functions that we already wrote. So you have to have all of these inline methods written for each of these animal, location, and zoo animal, for example, in order for this to work. So down in main then, I just asked if animal 1 was equivalent to animal 2 using the double equals operator, and we know that they're different. So if I executed the code down here, it says that it's a different animal. And so that gives you an example of several things here. Number 1, we did operator overloading. We did an inline method, which means it's a method that's written all at once without a prototype line. You have to have that method defined before you try to use it anywhere. And notice how I organized this. I did the structure animal, and then I did the inline method for animal. I did the location, and then I did the inline method for location, and then I did animal, and etc. And then in main, well then actually what happens then is I no longer have to have my compare locations because I've basically replaced all of that code. So I'm actually going to clean this up just a little bit. I do want to keep my show animal. I'm not going, and I could actually still use all of these as an example of just different animals, etc. I'm going to leave that code in there, but I no longer need the compare locations method because I've written them as inline methods. And then when you're all done, again, you would copy this code execution here and etc. below main. So that gives you a summary of how to set up your structures assignment. It also gives you an overview. Several things that we talked about here is when I have a structure within a structure, or this would also apply to a class within a class. Remember that I'm talking about this aggregation. That's nesting structures, and I want to talk about a HAZA relationship. It talked to you about how to declare structures, how to access structures, how to pass a structure to an array, and you want to pass it by reference as a constant. And actually, we probably would want to do that with our inline methods. I don't actually know if that would work, but I'm not going to try it right now. This video is kind of long enough. But that should kind of wrap up what you guys need to do, except you guys are going to be using a person, an address, and a person info, okay? To make your life just a little bit easier, if you guys want to shorten up the address and only use like city and state, I'm okay with that, so you don't have to have as many member comparisons that you'd have to do. All right, that should be it.